Hi everyone, my name is Aarushi. I've been a Go developer for about 1.5 years now. And recently, after attending an after party at JSConf, I realized how cool front-end developers actually are, and realized I want to do some of that work as well. But I didn't really want to have to dive full on into the whole the JavaScript ecosystem and learn all of the different frameworks. And that's why I started dabbling with Webassembly. As a way to just be able to use language that I'm quite familiar with to just bring it to the front end. So to set up what the talk will be about, firstly I want to talk about the what, whys, and hows of WebAssembly and Go. Then I want to talk about the Go specifics of how do you actually get Go down to WebAssembly and running in your browser. And then I want to talk about how you can call JavaScript from Go and Go from JavaScript. And then I want to introduce some frameworks that are already existing. And then I have some demos to show you as an introduction to how you can also get started and some of the caveats that I ran into. So hopefully you can avoid those. And lastly, of course, with any application, you want to have tests and you want to be able to deploy to production easily. So I bring in a small demo of how you can do that as well. OK, so what exactly is WASM or WebAssembly? If you go to their website, they basically describe it as a binary instruction format for a stack-based virtual machine, which I guess is a lot of jargon and kind of difficult to understand. So the way that I think of WebAssembly is more of a compile target rather than a language itself. So essentially, you can take a server-side language, such as Go, Rust, or Python, compile it down to WebAssembly, bytecode, and then run that module in your browser. And most major browsers currently support WebAssembly, except I think Safari, but there are ways around that as well. OK, so how do you actually do that? So how do you actually get Go down to WebAssembly bytecode and then running in your browser? So I guess most of you, if you've ran a Go program before, are familiar with this Go build command with some differences. So for example, we set the Go operating system to JavaScript. We set the architecture to WASM, and then we just build it. So what happens with this command is your main.go gets compiled down to your main.wasm, which is just a binary, which is then fetched and then ran in your browser alongside other WebAssembly aspects as well, such as import objects, memory objects, which we'll get into in a little bit. OK, so instantiating a WASM module. So I mentioned main.wasm, as you can see. And you can also see this go.import object. So basically what's happening here is that we are fetching our main.wasm, which is just your bytecode, and we're also getting our go.import object. So this go.import object is where all of your JavaScript functions live that allow you to actually call JavaScript from Go. So this go.import object comes from your wasm exec.js, which is very important when you're using Go for WebAssembly. And your instantiate streaming is what does the fetching of your bytecode, compiling, and then instantiating a WASM module. And then lastly, the important bit here is your result.instance, which is your actual instance of your WASM module. So this contains the module plus some functions that you can import and export, so both from JavaScript and a server-side language, as well as exposing linear memory, and you can also create memory objects, which in this case we're not doing because we don't need it at the moment. OK, so we've discussed a little bit of why we would want, of how you do it. I want to talk about why we would want to run Go in your front end. So one of the main arguments for WebAssembly is speed. So two things that make WebAssembly quite faster than JavaScript. Number one is the fact that WASM files tend to be smaller than JavaScript, so it's quicker to fetch those files from the server. And if you compress that file down, it's even smaller, becoming even faster. And the second reason is basically the way that JavaScript compiles down, the steps are JavaScript down to its abstract tree syntax, down to bytecode. And then it runs in your browser. But WebAssembly is already bytecode, so the only process left is to decode that bytecode and ensure that there's no errors before running. So removing that extra step makes it faster as well. So while speed is important, I don't think speed is the only reason for using a new technology or tool. So, I mean, we've been using JavaScript for a long time in the front end, and it does work well for a lot of use cases. So I think the other reasons behind why you would want to actually introduce WebAssembly is language diversity. So the idea of being able to use different languages for different use cases, I think just gives you more flexibility. And I think it makes, I guess, front-end development a little bit more accessible to more people. So if you're used to a certain language already and you don't want to go through that learning curve just yet, you can just use your a well-known language and run it in the browser. Secondly, I think familiar tooling is quite important as well. So that kind of aids with decreasing that learning curve. So if you're already familiar with certain tools, certain syntaxes, it's nice to be able to just use the same things for both back-end and front-end. And lastly, I like the idea of languages like Go following in the footsteps of Node.js, where you can just share back-end and front-end code. I think that's really valuable because even for full-stack developers, there's less context switching. It means that there might even be less divide between back-end developers and front-end developers in that you don't need to have a team of specifically back-end developers and specifically front-end developers. Okay, so I want to talk about some of the Go specifics of how you actually get what's actually involved with getting everything running. So firstly, we have the syscall.js package, which is basically just your JavaScript interface. So it basically provides a range of different functions that actually allow you to call your JavaScript code from Go. And you've got your compiler target, obviously WASM. And then the important thing is this wasm_exec file, which is just a JavaScript file with a few different responsibilities. So number one, it sets up a Go object, a Go class, which we then instantiate and run. So what this Go class actually does, it's actually what allows you to call to use all of those JavaScript functions in that syscall.js package. So things like it introduces things like copy bytes to JS, which actually allows you to copy all of your Go values down to JavaScript. It sets up a function so that when you write print line statements, it maps that to your console log. It also does things like graceful error handling. So it takes your Go program's error codes and then prints it out to the console for you. So basically, without this wasm_exec and this Go object, a lot of the functions that are provided with the syscall.js package would not work. And wasm_exec also allows you to take advantage of your WASM linear memory. So basically, all WASM modules expose some level of linear memory, which becomes quite important in that it speeds up sharing code and sharing values between JavaScript and Go. So just to talk about calling JavaScript code from Go. So this is an example of setting up your canvas purely in Go, so you're not using any JavaScript. So firstly, we get the JavaScript window, then we get the document, And then we can call get element by ID and actually get access to that element in our DOM. What you can see, though, is basically we're calling all of the same JavaScript functions and values that exist, but we're just wrapping them in Go code. So for example, normally for get element by ID, you would just use the dot operator, and you would do dot get element by ID and pass in the element's ID. So when you want to call a JavaScript function, we get this function called dot call, which just executes a JavaScript function, and the second parameter is just your arguments that you want to pass to that JavaScript function. And then the next two things that are important as well are the getters and the setters. So for things like being able to get JavaScript attributes, normally you would just be able to do window.innerWidth. In this case, we wrap it in a Go function called .get. We pass in the actual attribute as an argument, and then we convert it down to a Go value. And then lastly is set as well. So normally you can just do square canvas dot height equals whatever height you want to set. But in this case, because we want to use purely Go, we wrap it in a function called dot set, which under the hood then calls dot height and sets your height. And the second parameter, again, is the value that you want to be setting. So what you might notice about this is basically that this is basically just JavaScript code, but wrapped in Go. So in this case, it doesn't really provide you with any performance benefits, any readability, or anything that useful. And if anything, it probably just bloats your code and makes it a little bit more difficult to read. But that is an example of how you can actually just call JavaScript functions from Go. But what I think is more interesting is actually being able to call Go from JavaScript. So this is a matter of being able to write your Go function and use it just as a normal JavaScript function. So the way that that is done in Go is you define a function. So in our case, we've got an apply filter function with the signature with the arguments being this, comma args, and we return an interface. So this is basically a JavaScript this, which just allows you to access the fields in your JavaScript object. And args is all of the values that you want to pass to this apply filter function. So for example, in this case, we're basically just getting all of the arguments that we've passed, and then we're applying a filter such as make invert, make red, and then we copy those bytes back to JS, and we return that as an interface. But that interface is then later used to convert to a JavaScript value, which you'll see in the next 2 lines of code. So this syscall.js package provides you with a js.func_of, which is just a wrapper function. It takes your Go function, wraps it, and returns a JavaScript function, which is under the hood represented as js.value. Once you have that apply filter func, you can just set that globally, and it's accessible from JavaScript. But what you might notice about this is the fact that we're just setting, this means that if we're just setting a bunch of functions globally and polluting that space for JavaScript, right? So what WebAssembly actually lets you do as well, which isn't supported by Go yet, but it is supported in other languages such as Rust. It provides an object called exports, which is basically just being able, so that means you can just have a list of all of your Go functions within the WASM instance and still call them from JavaScript without having to actually pollute that global space in your JavaScript. So it's similar, it's basically the exact opposite of the import object that we talked about before. So where import object is a bunch of JavaScript functions that we can call from Go, exports is the other way around. It's a bunch of Go functions that we can call from JavaScript. Yeah, so there's not support for that yet, but I think that's quite an interesting way of handling that, which Rust does. Okay, cool. So I wanted to show you, I guess, like my version of a Hello World application for getting started with WebAssembly and some of the caveats that I ran into with this. So I'm using Go 112 for this, and I'll show you what it does. So it's just an animation that I tried out where you're writing a word with these like circles, and then you can click it and it refreshes and writes a new word. But what you might notice here is that firstly, it was really, really slow to appear. And the circles are quite slow to grow as well. And then when you click on it, I've clicked it here, and it still took some time to reload and write a new word. So I want to just talk about why that is. So the way that this code works is basically we've got two canvases. One is for writing the word WASM, and one on top of it for the circles that we want to draw. So what we do is we write the word, we get all of the image data from our base canvas, and then we check whether there's an actual pixel there. And if there is, then we can say, okay, this might be a possible position that we can write our circles. But what you'll see is that in this for loop, we've got a bunch of if statements. So the way that pixels are represented in JavaScript is RGBA. So I'm taking 4 pixels and checking each one to see if the value is greater than 0, meaning that there is something there. But what's happening under the hood here is because we've got JavaScript numbers, right? When our image data is represented as JavaScript numbers. So we have to convert that down to our Go value. So we call this .int function. But what's happening under the hood here is we're using the unsafe package. We're getting an arbitrary pointer. Then we convert that back to a float64 pointer because JavaScript numbers are represented as floats. And then we can get that value, and then we convert it to an int. So that's a few different steps that we have to take, and we're using the unsafe package. So it's not great, and that's why it's so slow. With Go 112, what it does provide is the ability to copy all of your bytes from Go to JS, but not vice versa. So it doesn't allow you to just get access to those underlying bytes in your underlying array in the slice. But with the copying Go values to JavaScript, because we're accessing WASM's linear memory, we've got access to the actual just values under the hood, and we're able to just fill that space in memory with the values that we want for JavaScript. But we can't do that vice versa with 1.12. And that's where Go 1.13 is great, because they've now introduced 2 functions. One function for copying over the JS values to Go, which basically just means that we create a slice of whatever size we want. Then with our WASM exec JS file, so the copy bytes to JS. Copy bytes to Go. It gets the memory address for where that underlying array for that slice exists, and then it just copies all of those values into that array. So then we already have access to it, and we don't have to do all of these extra steps of getting the pointers and the values and converting different values. And so to show you how much faster that actually ended up being, I've got a better demo that I think is easier to understand. Okay, so ignore my sad face there, but if you can see, it's kind of hovering around 1 frame per second, less than 2 frames per second, right? For getting this image data and filtering it to be gray. So this was using Go 1.12. And then when I used 1.13, then you can see it went up to 60 frames per second, which is like a 30%, 30 times the speed, which is awesome. So my suggestion would be if you want to experiment with WebAssembly, to use 1.13. Okay, so those are some of the introductions into WebAssembly and how things work briefly under the hood. Now I want to talk about some of the frameworks that already exist and some of the work that people are already putting into this. So frameworks such as vugu and vecti, which are based on Vue and React, respectively, but purely in Go. So I've focused on vugu. That's the one that I've used, and I can introduce that a little bit. So basically, vugu is UI development in Go. It's very similar to Vue.js in that it lets you do like if statements and for loops and that kind of thing. It has a very active community on Slack, so the person that maintains it answers your questions quite a lot, and I think it's an opportunity to contribute to open source as well, because there are features that are still missing and still being worked on. So to show you an example of how vugu actually works, I'll just show you. Okay, so basically this is just a really small app. You can see it running here. So it gets dad jokes. When you click it, it makes the call and gets kind of a lame dad joke, which I think is kind of funny though. And yeah, so that's how that works. And this is purely in Go, compiled down to WebAssembly. And what it actually looks like when you write it, so you write all of your code in this .vugu file. So in my case, I've kind of just put it all in one file, but you can just split things out into separate components, separate CSS files, and your script code. So it's very easy to read, obviously. It's just your HTML code to set up that little box, to set up a button. But what's interesting is the VG if. So that's for the spinner. So when I'm making a call, if it's loading, it will appear. And then the VG if for actually showing the dad joke. So if it's not equal to empty string, then show it. So to have a look at the actual Go code, it's literally just your everyday normal Go code. You define your root data with all of the values that you want, and then you can add a event listener to any of your components that you want. So in my case, a click at click, and I just call the function that I want to be invoked. So it's very simple. It's just because this is I/O blocking, I've used a Go routine to do this, and I'm using event env to do syncing for accessing my data in my struct. So yeah, so you can see your imports work as normal. I'm using the net HTTP package to actually make the call, and binding using JSON bindings, and then yeah. It works just like that. So the way that this works is you define all of your code in your .vugu file, then it compiles it down to your .go file. So it does all of these things like building your virtual DOM, setting up your struct here, which you set up in your .vugu file. Generally, you don't edit this file. If you wanted to add more things to your structs, you would do it in a separate file. What the nice thing about vugu is all of this creating a vugu file and compiling it down to WASM can be handled by your dev server. You can also do it manually as well if you wanted. But you can just use your, with the vugu gen command, but you can just use a dev server as well. And just to see what's happening here. Yeah, okay, so the way that basically things work in vugu is there's three main things that you need. So you need to have your basically have your root component, which is the root component of your document, and everything else goes inside of it. Then you have your environment that you want to run in. So for WebAssembly, it's JS-env, and then you can just run it normally with just if you use your the dev server. Okay, so that was like a brief introduction into vugu. And I also said before that we would talk about testing and CI. So with WebAssembly, it is possible to run it in your Node.js environment rather than in the browser. But like I said at the start of this talk, I didn't really want to go down that path of JavaScript at all. So when I was doing some research, I started using WASM browser test, which basically just does all of the setup for so that you can run your tests and your actual WebAssembly headlessly in Chrome. It does all of the setup for you. And there's the link for it as well, if you want. The steps basically are you grab that WASM browser test file, you change it, you rename it to Go.js WASM exec and move it into your Go path. And then testing it, executing it is your usual Go test function command, but obviously setting your operating system and your architecture to JS and WASM respectively. Yeah, so the last thing that I wanted to try out with WebAssembly was actually, I guess, running all of my tests in Travis CI and deploying it. So it's very simple to just set up your Docker file as you would normally to containerize that and then run it on Heroku or wherever you're hosting it. So it's all of the same commands that I showed you earlier with compiling it down, compiling your main.go down to WASM, and then running that in Travis. So I'll just show you that as well. I don't know if you can see that as well. But yeah, so basically I'm doing all of the setting up the WASM browser tests, getting everything that I need set up for that. So moving it, renaming it, and moving it to my Go path. And then just running the test and pushing everything up. And then the final, I guess, sort of to put it all together, what it ends up looking like is I don't know if that's going to work. Yeah, so that it just works, and yeah. So the last thing that I wanted to talk about with this was earlier we talked about JavaScript, calling JavaScript from Go and calling Go from JavaScript, and we noticed that purely using Go it doesn't seem that useful. So the way that I think that this WebAssembly should be used is more in combination with JavaScript. So for that final app that I showed you, rather than setting everything up with Go, I kind of use 50% JavaScript to actually set things up. So things like getting access to the webcam and getting all of the image data, that's all done with JavaScript. And the stuff that's actually done in Go is the actual filtering, which I thought was more useful to actually write that logic in Go, and the very basic setup in JavaScript seemed fine to me, and it didn't make the code as, I guess, hideous as before. Yeah, so to summarize, I think that while WebAssembly is really cool, I think it's more to work alongside JavaScript rather than to completely replace it. There are arguments for performance, so things like smaller file sizes, less steps to actually compiling and deploying. And while performance is important, there are lots of other reasons for why you would want to use WebAssembly. There's a few different frameworks out there already, which is cool because it's quite early stages, but people are already jumping on this. There's an active community around it, and I think there's lots of opportunities for people to contribute to open source if they want. Yeah, and lastly, I've included some resources here. So the first one is the Go wiki for WebAssembly, and it's got some really cool examples of things other people have done, and different frameworks, and all of the, I guess, the things that you might want to get started with Go and WebAssembly. And then I've got links to my code if you wanted to have something as a template to get started with. And yeah, and you can hit me up at on Twitter if you want. yeah, and I hope this talk inspired you to start using WebAssembly in the front end and exploring your creative side. Thanks.
Thank you, Aarushi. Amazing talk. And congratulations on the live working examples. All right. First, before questions, we have a small diploma for you.
Thanks.
And a present.
Thanks.
This is a matryoshka, gopher matryoshka. All right. So, do you have any questions? If we have some problems with translations, I'll help you with that. We're going to have a present for a best question, so please remember them.
Thank you for your presentation. And the question is, in your opinion, WebAssembly will replace JavaScript, or will WebAssembly make JavaScript more valuable in future?
I think it'll make JavaScript more available, so I think it's important to use them together because JavaScript already does a bunch of things perfectly well. And there's no real need to completely replace JavaScript.
Okay, thank you.
Thank you very much for your report. Could you mention any projects which are used this technology in development of front-end?
I don't know of any projects that are in production right now, but the wiki that I've linked has a bunch of different examples of side projects and examples that people have tried out.
Any more questions?
Thank you for your presentation, and my questions about vugu. If I understand correctly, vugu have one file. What contains CSS and Go code and other. How can I write my Go code for vugu? For example, I can create this Go file in another edition, id for example, and then copy this in vugu file. I understand correctly?
Sorry, I didn't understand the last part.
It's more difficult using this vugu file because this file contained more languages. And my question is how I can more easy using vugu file.
So I guess in my example, I put everything in one file, but what you could actually just be doing is creating your structs in a .go file and importing that into your vugu file in the script tags.
Import with existing functions in vugu?
Sorry?
How I can import my functions in vugu file?
I think it's just your normal, the way that you would with JavaScript files. There's documentation on it, so I can give you that later if you'd like.
Oh, I understand. Thank you.
Hi, thank you. And what about compatibility of WebAssembly and mobile browsers?
I haven't tried it out for mobile browsers. But I think some of the other examples that I've seen, WebAssembly seems to work fine in quite a few mobile browsers as well.
ARM isn't a problem for WebAssembly?
I'm not sure about that.
Okay, thank you.
Hello, thank you for your presentation. I have such question. You said about some advantages of WebAssembly. You said about diversity, combining backend and frontend, and maybe you have some benchmarks on something like that. Let me say it correctly. Is WebAssembly faster than regular JavaScript?
Yeah. So as I mentioned, it's faster in that in the process, the compiling process, and being smaller. So that's the aspect of WebAssembly, but I think it's that Go code or Rust code is better used for certain use cases, right? So things like VR or games where you want more instant action, or like feedback.
Yeah, okay, thanks.
Any more questions? Here?
Hi, thank you for presentation. My question is, were there any drawbacks or issues that you stuck on while your first application development?
I think the main issues are that not all of the features are completely ready yet. So things like what I mentioned about how slow it was initially, because they initially didn't have that way of converting your JavaScript values to your Go values. And then things like when you look around for WebAssembly, different languages are more mature in that space. So for example, Rust is far more mature. So that's where I found out about this like concept of exports and putting your functions in this exports object. So I guess that gets kind of confusing because you see this like cool way of doing something, but then you realize, oh wait, Go doesn't actually support that, and it kind of, you spend a few days being like, why doesn't this work? And then you realize, well, okay, it's not yet.
Thank you.
Hello, thank you for your presentation. As we know, JavaScript runs in one thread. Is there any cases to run WebAssembly in parallel mode?
I'm not sure. I'm not really sure. Yeah,
Okay,
I haven't thought
thank you.
about that yet.
Hello, thank you for your talk. As I see Wasm, I see Wasm as an interesting technology, but I'm afraid that it's not really production ready because there are very little amount of companies that use it. So I'm interested, and I want to help Wasm to become more production ready. Is there any open source driven communities or something like that that develops technology?
So in terms of open source, so there are, like on that wiki that I've linked, there are different frameworks that you can contribute to. There's things that you can drive as well and start your own thing. So for example, debugging isn't a thing yet. WebAssembly has an entire like RPC about debugging, but that's not supported in Go. So there's opportunities there to see what you can do. Yeah, and like lots of different things aren't completely implemented. So creating issues or maybe creating pull requests would definitely help make it more production ready.
Thank you.
More questions? There was a question here. No? All right. Thank you, Aarushi. Thank you very much. Sorry, my bad. You need to choose the best question. Do you remember them?
Yeah, I do. I think the open source question was the best, of how you actually contribute to open source and make things production ready.
Yeah, I agree. Please tell us who you are and why did you ask this question?
Hello, I'm a Go developer from. Hello, I'm Go developer from Lamoda, and I'm really interested in JavaScript and the ways we could develop in JavaScript from our backend perspective. And I don't really know JavaScript, but because of Wasm, I could use it a little bit more, and I'm interested in making Wasm become more popular and more common in backend community.
Thank you very much. This is your book.